Hey everyone, it's Bradley Bush with another algebra video for you. Today we're talking about geometric sequences, specifically how to find the nth partial sum of a geometric sequence, and we have some worked examples. If this is your first time to my channel, I'm happy you're here. If you're returning, thanks so much for coming back. If you enjoy it or if you find it helpful at all, please consider subscribing to the channel, giving me a thumbs up, or leave a comment. First question, what is a geometric sequence? A geometric sequence is a sequence where each term after the first is computed by multiplying the previous term by the same non-zero constant, which we call the common ratio. The common ratio can be found by taking the second term, a sub 2, and dividing a sub 2 by the first term, a sub 1. So if we look at an example, we have the sequence 1, 5, 25, 125, and 625, and it keeps going on forever, which, by the way, is an infinite geometric sequence. So we just took the first n terms. It would be considered a finite geometric sequence. So if we look at this, our first term is 1, our a sub 1 is 1, our a sub 2 is 5. So if we take 5 divided by 1, we get 5. So 5 is the common ratio. So if we notice, 1 times 5 gives us 5, 5 times 5 gives us 25, 25 times 5 gives us 125, and so on. So each term is computed by taking the previous term and multiplying by 5 after you move away from the very first term, which is just given in every sequence, every geometric sequence. In our next example, the first term is 9, and the second term is -3. You take -3 divided by 9, and you get -1/3. That is our common ratio. So 9 multiplied by -1/3 gives me -3. -3 multiplied by -1/3 gives me 1. 1 multiplied by -1/3 gives me -1/3, and so on. Those are the basics of a geometric sequence. The nth partial sum, the sum of the first n terms of a geometric sequence, is called the nth partial sum. And we can write it like so, where you have s sub n, and then you just literally sum the first n terms, one by one. That can totally work, but it's a little cumbersome, because what if you're trying to sum like the first 100 terms or the first 1,000 terms? That's kind of painful, just even thinking about it. So luckily for us, we have another formula that is a little more concise. And it is s sub n equals, it's a fraction. In the top we have a sub 1 multiplied by quantity, 1 minus r to the n. And in the denominator we have 1 minus r. R is the common ratio, and a sub 1 is the first term in the sequence. And by the way, r cannot equal 1, or the universe explodes, because you have 0 in the denominator. Let's do an example. Find the sum of the first 11 terms of the sequence 4, -12, 36, -108, and so on. And we have our definition for the nth partial sum. The first thing we want to do is we want to find the common ratio, because we can't really do anything without that. Our first term is 4, so we'll put that in the denominator. Our second term is -12. We'll put that in the numerator. This gives us -3. -3 is our common ratio. Now we can just write out our problem here. So s sub n equals a sub 1, which was 4, times 1 minus the common ratio, which is -3 to the n. We're doing 11 here, so s sub n really should be 11. And then we will put 11 here as the exponent on the r in the numerator. And we have all of that over 1 minus the common ratio again, which is -3. What is -3 to the 11? It looks like kind of a nasty number. Well, let me tell you what -3 to the 11 is. I'm just writing out the rest of this problem. So 4 is still on the outside. and then we have quantity 1 minus, and that's where we put negative 3 to the 11, which happens to be negative 177,147. It's a lot of sevens. And this is all over 1 minus a minus. That gives us a plus. So 1 plus 3, which gives us 4. And let's keep simplifying here. We have 4. We have another plus plus. So, minus minus, which gives us a plus. So the two negatives give us a plus because a negative times a negative is a positive. That gives us 1 plus 177,147, which is 177,148. Let's write that down. 177,148. And we still have our 4 in the bottom. We also see that the 4's cancel in the top and in the bottom. And that leaves us just with 177,148, which is our answer. That's the sum of the first 11 terms of this geometric sequence. Let's try another example. Find the sum of... Interesting. Here we have the sum of, from I equals 1 to 10, of 5 times 2 to the I. We could just write it all out, right? Because this is summation notation here. And by the way, when you're finding the sum of a geometric sequence, it's called a geometric series. And this one, we're only doing the first 10 terms, so it's a finite geometric series. But we'll get to that later, actually in another video. If you want to watch more about that geometric series, please look at my video on geometric series in my algebra playlist. So the first term in this sum, I equals 1, would be 5 times 2 to the 1, 5 times 2 to the 2, 5 times 2 to the 3, and so on up to 5 times 2 to the 10. So we just replace the I with whatever I equals at that term. That's going to be, we could do it. They're 10 terms, right? It wouldn't kill us. It might maim us permanently for life. There's just a faster way, right? We could just use our formula that we have for the nth partial sum. We would just need one thing. We already have our first term, which is 10. Our first term in our sequence. We just need the r. So we compute the first two terms, and we have 10 and 20. We can use those, and we can compute the common ratio, which is 20 over 10, which gives us 2. So 2 is our common ratio, and now we can just write out our nth partial sum. We want the 10th partial sum, because we're summing from I equals 1 to 10. So S sub 10 gives us A1, which is 10, multiplied by 1 minus R, which is 2, to the N, which is 10. And at the bottom we have 1 minus 2. So the 1 minus 2, let's just put that down right now. That just gives us negative 1. What is 2 to the 10th power? That is 1024. So we have 10, and we have 1 minus 1024. 1 minus 1024 gives us negative 1023. So we have 10 times negative 1023 all over negative 1. The 10 times negative 1023 gives us negative 10,230 all over negative 1, and the negatives will cancel, and that just leaves us with a positive 10,230. That's it. Hope you enjoyed it. Thanks for watching.